All right, day 14, section 6.3. This section is not that it's going to be a review of the previous section, but just like we had with our parallel lines and our alternate interior, alternate exterior angles back in that chapter, we had a whole section that was basically a converse of the previous section. So it's a lot of redundancy. It also works as a review of the ideas of those properties of a parallelogram. So yesterday we said a bunch of times, if a quadrilateral is a parallelogram, that was the hypothesis. Then we gave some property as the conclusion. Now we're going to do the converse of that. We're now going to be stating the property as the hypothesis, and then we get to use the conclusion to say that this quadrilateral is then a parallelogram. So just to speed these up, I think I'm going to start writing these in, and then we'll have more time to either explain some stuff or just make the videos just a little bit shorter for you guys. So theorem 6a, if both pairs of opposite sides of a quadrilateral are congruent, so here we go, opposite sides congruent, both pairs need that to occur, then the quadrilateral is a parallelogram, okay? So then we indeed have a parallelogram here. So it's important that both of these occur, not just one pair of opposite sides, but both pairs of opposite sides. Theorem 6.9, if an angle of a quadrilateral is supplementary to both of its consecutive angles. So that means B plus A is 180 and B plus C is 180. Then the quadrilateral is a parallelogram. And yeah, you only need to do that for one, because if B and A are supplementary and B and C are supplementary, we know B and D are opposite, they're congruent, and then D and C. So it all should kind of unfold from there. So we only need to find it once. Six ten, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So just like we need both pairs of opposite sides to be congruent, we need both pairs of opposite angles to be congruent. So I'll zoom out right there if you guys want to pause right there and kind of take a look at that, and then we can move on. So the homework problems for this, and even on the homework quiz, they're very algebraic, and it's almost as if like they could be a problem from the previous section using all the theorems. So for what value of y must PQRS be a parallelogram? Okay, so we're only dealing with side lengths here. So from the theorems we just talked about, we know that the opposite sides, both pairs of them, have to be congruent. So that means x plus 2 has to equal y. Now we don't like that to solve because we have two different variables involved. So we're maybe thinking that we have to solve this like a system of equations. But if you look at this next one, it seems like they help us out a little bit there, and we have only x's involved in this next one. So we're going to work with that one. Subtract 2x from both sides, add 5 to both sides. So we have x equals, that cancels, 6. And if x equals 6, we can now bring that over here and say 6 plus 2 equals y. So y equals 8. So for what value of y? Our answer is y must equal 8. All right, using the diagram at the right, for what values of x and y must EFGH be a parallelogram? So this time they give us the angle measures. We could try and say that opposite angles here are congruent. So these opposite angles here are congruent. Notice when I do that, I involve x's and y's, x's and y's. We can try and go that route, but we're going to try to avoid that, just like we were able to avoid that in the previous problem. We know that consecutive angles must be supplementary. So that means that I'm going to go M with E because they both have Y's. I'm not going to go this way quite yet. So 3Y plus 2 plus Y plus 10 equals 180. That gives me 4Y plus 12 equals 180. Subtract the 12. That gives me 4Y equals 168. Y equals 42. This also has to be true if we want to find the x value. So this is 16x plus 20 equals 180. 16x equals 160. X equals 10. Just zoom out there. Good place for you to pause it to take a look at that work. All right, theorem 611. So the next property of a parallelogram. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. 612. If one pair of opposite sides of a quadrilateral, so this is if one pair is both parallel and congruent, then it's a parallelogram. So in the past, we've needed both pairs to be congruent. Now they're saying if this is not only congruent, but also parallel, then basically it's going to deem the other side to be congruent as well. So you only need one pair for theorem 612. So can you prove that the quadrilateral is a parallelogram based on the given information? So we can say that AB is congruent to DC. We can see they're both 5. Also, the measure of angle A plus the measure of angle D equals 180 because 50 plus 130 equals 180. And why does that matter? It matters because if we go back to what I prefaced earlier, these are same side interior angles. And since they are supplementary, then that makes AB and DC parallel. So AB and DC, they're both congruent. and they're parallel. So we satisfied both for theorem 612. All right, so try it again. Can you prove that the quadrilateral is a parallelogram based on the given information? So what they give us, it's a little bit harder to see in this one. These are parallel, and these are congruent. In that situation, no. Not enough information. Because we want the congruence to be on the same segments that are indeed parallel. So unfortunately, they're on separate ones. All right, a truck sits on the platform of a vehicle lift. Two moving arms raise the platform until a mechanic can fit underneath. Why will the truck always remain parallel to the ground as it's lifted? So they want to know why is it safe to say that the truck and the ground will always be parallel. And we're not going to write it out, we're just going to talk it out. It's because we have these arms that are moving are both 6 feet, so they are congruent. So the arms are congruent, and we have the platform between the arms and the ground between the arms are congruent. So basically we have each pair of opposite sides are congruent, which means this quadrilateral is indeed a parallelogram. Therefore, definition of a parallelogram, opposite sides are parallel. All right, so we have this concept summary here. It's a nice way to kind of goes through all of the ideas and the theorems for a quadrilateral being a parallelogram. And remember, they go both ways. Okay? They go both ways with a converse. All right, take your time, look at this homework. You guys are going to have a homework quiz on the same day just because it's a Friday before spring break. So I want you guys to get that grade done with, get a nice good idea of where you stand during this closure period through 14 days. And make sure you ask any questions, come through my office hours before you take that homework quiz. Give yourself some time to go through this homework. That's why I tried to make the video a little bit shorter. And then take the homework quiz by the end of the day.